Hello everybody, welcome to today's challenge. Today we have this simple algebra before us here. The question is solve for x and x to the power of 4 minus 10 equal to x to the power of 2 minus 4. So how do we solve for the value of x in this challenge? It's easy. So let's take our first step here, which is solution. Solution. Okay. So now if you look at the right hand side of this equation, we can bring something of this nature from the left hand side of this equation. How do I mean? 16 can be written as 4 to the power of 2, and x to the power of 4 can be written as x to the power of 2 or to the power of 2. So let's go ahead and rewrite this side of this equation. This is going to give us here, we're going to have our x to the power of 2 bracket or to the power of 2 minus 4 to the power of 2 equal to x to the power of 2 minus 4. What we do here is just to move the whole of this quantity to this side of this equation. So let's do that. This will give us x to the power of 2 bracket or to the power of 2, then minus 4 to the power of 2. Let's put this in the square bracket. Then if we move the whole of this to the left hand side of the equation, this is going to give us minus a bracket our x to the power of 2 minus 4 close bracket everything equal to 0. Good. Now from here we can draw up the difference of two square here. Doing that, we're going to get something of this from this side of the equation. We know the difference of two squares says that if you have your a to the power of 2 minus b to the power of 2, this is equal to, we have our a plus b, bracket open and close the bracket a minus b. You know this, right? So we want to evoke this law here. We want to put it in this place here. So this is going to give us our bracket open, our x to the power of 2, right? So there plus our 4 close bracket, then bracket our x to the power of 2 minus 4 close bracket, then minus our x to the power of 2 minus 4 close bracket, everything equal to 0. So you discover that this is also there. So what we do, we factor out x to the power of 2 minus 4. So if we do that, it's going to give us bracket open x to the power of 2 plus, minus 4 close bracket, bracket. If we use this to divide everything here, we are left with this 10 here. So this is going to give us x to the power of 2 plus our 4. Then let's bring in our minus here now. So minus, if we use this to divide this, we are left with 1. So this is going to give us 1 close bracket, everything equal to 0. Then we can carry out this simplification here, and this will give us plus 3, right? So here we're going to have our x to the power of 2 minus 4 close bracket, bracket x to the power of 2 plus 3 close bracket, everything equal to 0. Now remember our zero product law, which says that if you have your a times b equal to 0, this implies that our a is equal to 0 or our b equal to 0. Okay, so again, we want to make use of this law here. So we going to equate this to 0, equate this to 0. So this now implies that our x to the power of 2 minus 4 equal to 0, or our x to the power of 2 plus 3 equal to 0. So we have two cases here now. So let's take case 1. So we're going to have here case 1. So what is our case 1? Look at this here. We're going to have our x to the power of 2 minus 4 equal to 0. So send this to this side of the equation. We're going to have x then to the power of 2 equal to 4. So what we do, we take the square root of both sides of this equation. So this is going to give us x to the power of 2, the square root of it equal to the square root of 4. And at this point, we introduce our plus minus to this side. Okay, so this radical goes with this 2. There we now have here x is equal to plus minus our 2. So we have two answers from the first case here. So we have here, therefore, our x1 is equal to positive 2 and our x2 is equal to negative 2. So let's keep these answers. Because at the end of the day, we're going to do some verification to these answers. So let's take our case 2. So we have our case 2. What is our case 2? Look at our case 2 here. We have this, right? So let's solve for our x2. So we're going to have here our x to the power of 2 plus 3 equal to 0. From our education, we're going to have imaginary root from here. So we move this to this side of the equation. So we have here x to the power of 2 equal to minus 3. So what we do to eliminate this radical, we take the square root of both sides. So this is going to give us x to the power of 2, square root of it equal to square root of minus 3. Again, we introduce our plus minus here. Okay? Alright, so let's continue on this side of it and see what this gives us. Now, from here, this will leave here. Okay, so we now have our x. So we now left with our x will now be equal to a plus minus. Now, the square root of this figure can be written as our square root of minus 1 times the square root of 3. Again, we know that our square root of minus 1 is equal to iota, right? So if it is equal to I, then we can now rewrite everything here as our x will now be equal to our plus minus square root of 3 iota. So we have two roots from here again. So this will give us here x3 is equal to plus the square root of 3 iota. And our x4 is equal to the square root minus the square root of 3 iota. Okay, so in all we have 4 roots for this challenge, which are these and this very one and this very one. But here we want to do a simple check if all 4 roots will satisfy the original equation. Look at our original equation here. So let's do a check. Now from here, this is the first root. Now so we want to check for first root, which is 2. So this is going to give us here our 2 all to the power of 4 minus 16 is equal to 2 all to the power of 2 minus 4. So what is 2 to the power of 4? That is 16. So we're going to have here 16 minus 16 equal to 4 minus 4. So 16 minus 16 will give us 0 and 4 minus 4 will give us 0. So it shows that the first answer, which is x equal to 2, satisfies the original equation. So let's do that for second one. The second one will also give us the same, but let's just check. So here we're going to have here our x to the power of 4 minus 16 equal to x to the power of 2 minus 4, right? So we have our our x2 to be minus 2. So from here, this is going to give us here minus 2 all to the power of 4 minus 16 equal to minus 2 all to the power of 2 minus 4. Again, what is 4 will affect this minus sign here. So minus 1 to the power of 4 will give us positive 1. And 2 to the power of 4 will give us 16. So again, we're going to have this to be positive 16 minus 16 equal to here. Minus 1 to the power of 2 will give us plus 1. And 2 to the power of 2 will give us 4. So we're going to have here positive 4 minus 4. Again, we're going to have this to be 0 equal to 0. So this shows that the second answer, x equals to minus 2, satisfies the original equation. So we take the third one. So again, we have our x to the power of 4 minus 16 equal to x to the power of 2 minus 4. So let's put in the third one, which is our square root of 3 iota. So this is going to give us here the square root of 3 iota all to the power of 4 minus 16. This is equal to the square root of 3 iota all to the power of 2 minus 4. Is right? Good. Again, we know that this power is affecting this separately and it's also affecting this separately. Same thing here. So let's go ahead and simplify this. So this is going to give us here square root of 3 all to the power of 4 there times I to the power of 4 minus 16 equal to the square root of 3 all to the power of 4 there times I to the power of 2 minus 4. Okay, so here it is easy. We can rewrite this radical and rewrite this radical. So this is same thing as 3 to the power of 1 all over 2 all to the power of 4 there times iota to the power of 4 minus 16 equal to 3 to the power of 1 all over 2 there all to the power of 2. Sorry, yes, 2, please. Sorry, yes, 2. Okay, 2 there times I to the power of 2 minus 4. Okay, now let's get the value for our iota first. We know that our iota, if we have your I to the power of 0, this will give us 1. Then I to the power of 1 will give us I. Then our I to the power of 2, this will give us minus 1. Then I to the power of 3, this will give us minus I. And I to the power of 4, this will give us positive 1 again. So from here, let's look at this. This power will cancel out this. So 2 here 1, 2 here we have 2. So we are left with 3 to the power of 2 times I to the power of 4 we've established, which is 1. So we have here times 1 then minus 16 equal to here. This will go with this. So we're going to have here 3. Then this is what? Minus 1. Look at it here. We have it to be minus 1. So this will now be times minus 1. Let's put this in bracket, then minus our 4, right? Good. So from here, we continue again. 3 to the power of 2 will give us 9. 9 times 1 will give us 9. So we have here 9 minus 16. This is equal to 3 times minus 1 will give us minus 3 minus 4. So 9 from 16, this will give us minus 7. This is equal to minus 3 minus 4 will give us minus 7. So it shows that the third answer again, this is correct. In other words, satisfy the original equation. All right, so let's take the last one, which is our minus root 3 iota. So we're going to have here our x to the power of 4 there minus 16 equal to our x to the power of 2 minus 4. This is similar to the one we just done now, but let's just go ahead and bring out all our values. So this is going to give us here bracket the square root of 3 minus here, please. Okay, iota all to the power of 4 then minus 16 equal to here minus the square root of 3 iota bracket close all to the power of 2 minus 4. So what we do here, already we've established the fact that this one will give us positive 1 and this will give us 9. That is 3 to the power of 2, which is 9. Then minus 1 to the power of 4 will give us positive. So everything here is going to give us again 9. Then minus, here we have 16. Equal again minus 1 to the power of 2 will give us positive. And square root of 3 iota to the power of 2, automatically we know that it will give us minus 3. So automatically it's going to give us minus 3 minus 4, of which it will give us here 9 minus 16 will give us minus 7 equal to minus 7. So this shows again that the fourth root satisfies the original equation. All right, so this brings us to the end of this math challenge. If you've learned something from this video tutorial, ranging from the solving down to the checking of the roots, then give the video a thumbs up. And if you have any question with regards to the procedure we use in solving this and also checking for the root, then drop it in the comment section. We'll reply to your comments. Thanks for watching Math Prowess. We bring more videos to you. Keep watching Math Prowess. Bye.